Hello, my name is Piotr Alexeyev, and today our lecture is concerned about the security issues of web applications development. Currently, our lecture is based on the slides of this book, Foundations of Security, what every programmer needs to know. You can go through this link and find more information about this book. And also you can download interesting code examples and even slides. This current presentation is based on from this particular link. So you feel free to follow this link. And currently, today our lecture is concerned about the following topics. We will start with the key security concepts like authentication, authorization, confidentiality, data or message integrity, accountability, availability, and non-repudiation. So we will go through all of these terms and realize what exactly do they mean. We will follow with the secure systems design. This is a topic with a section which is devoted to the specific of how to design, how to create your work, what will be done correctly, how to propose your solution for your particular project, which will be able to take into account all the security issues and take them in a good way. And later, four topics will be devoted to particular problems with security, like client-state manipulation, which is concerned about web applications, where, for example, a user can type something wrong or manipulate with HTML or requests, HTTP requests. The well-known SQL injection is another threat, is a well-known threat, and we will talk about this in this following topic. We also will talk about password security, how to deal with passwords, how to store these passwords, how to use salted caches, and so on. And we will end up with cross-domain security in web applications, which is quite valuable for web applications development issues. So perhaps you're already familiar with at least some of these topics. And I hope this information from my lecture will be also useful for you as well. And anyway, if you're very familiar, I hope you will find something interesting and useful for your future work. So let's go. Let's start with key security concepts. This slide is particularly describes why the security is important for web applications, which is quite obvious because what is web application? It's some sort of server side and some sort of user interface, which is derived, which is cut down from the server, and there is a strong interaction between the server and the clients and the user interface in the browser. So if this is so-called disconnected or distributed application, there's an ability to interact with this application and try to make something malicious. So that's why the security for web applications, particularly, is extremely important. It's important for any application, but for web applications, it's extremely important as well. And one can say that security is holistic. No one can say that the security is only a technical problem or something. Why? Because security concerns in three particular types. The first one is physical security. What does it mean? It basically means what if you have a server, you have to keep it in a safe place with safe doors, windows, so no one will be able to interact with your server. So no one will try to steal it, for example, or interact with its file system individually. So the next is what common thing is a technical security. It depends on how you implement your application, what technical things you can do with your application to make it more secure. It can be divided in application security itself. It might be divided to operating system security because your applications are relying on underlying operating system security features, and finally on network security. We will talk about this a bit later. And finally, the third type of security is policies and procedures. Well, the basic example, if you have very strong technical stuff, if you have very strong physical security in your application, that doesn't mean that your application is completely secure. Because, for example, your users may just basically write their passwords in yellow labels and stick them to the monitors, or just throw them away in the trash and someone can steal them afterwards. This is not quite obviously. That's why all of these three types of security are required. That's why security is holistic. So you cannot say you implemented security completely if you use, for example, only technical security. You have to have all three of these types of security being implemented correctly. Well, with physical security, I already started to talk to you. So, for example of a problem with physical security is, for example, a dumpster diving, when someone is trying to get some information from your trash. Sometimes it might be very, very useful because from the trash you can get information what actually people are doing there. So you can get a lot of things to do from this. And don't forget about limiting physical access to your computer equipment. Because if someone has physical access to your computer, he can or she can just take off your hard drive and write something he or she wished to there. It's not that problematic. Technological security started from application security. We can say, well, this is quite common architecture of a common web application. We can have a web browser with the user interface there. We have a firewall which protects entire our network from the internet and some of our outbound connections. We have a web server with our application with underlying operating system, and the usual stuff of web application is a web database server which also relies on underlying operating system. So you have to protect everything here. So you have to think about how users, how applications will get an access to the data. So, for example, a database server must be maximum protected from the user interface. So, user will not be able to connect to the database server itself. So, he or she will be able to do it through just web server, for example. So, you have to think about this. Network security is also interesting stuff because you have to think about basically what the network you have, what the underlying operating systems you have, and you have to install the latest updates to this operating system to cover some problems, some errors in this operating system, which allows you to assure yourself that no one will try to exploit these problems and no one will try to use them for example, for hacking your network or your application. And also, you have to use some tools, special tools like firewalls and intrusion detection systems. So this is quite common stuff for network security. And also, you can think about providing security on a network level, like a protocol of IP security, IPsec, which allows you to have verified connections between your hosts. So you have to also think about this. Unfortunately, this is not really often used in the real internet. So you also have to think about policies and procedures. This is the third type of security. Don't forget about well-known social engineering attack. What is it? And someone's calling to you and asking you to submit your password, or just say it, pronounce it. So no one have to ask you like this, because you cannot verify that this person is authorized to do this. So you have to follow these policies. You have to create these policies first, and you have to think how to implement them and how to manage them. So this is also very useful for security. And now let's go with 7 security concepts in detail: authentication, authorization, confidentiality, data management or message integrity, accountability, availability, and non-repudiation. Let's start from authentication. Well, basically, what is authentication? Authentication is a process that allows you to say that the person who are interacting with is a legal person. So if you're interacting with me, so you will be sure that me is Petr Alexeyev, and so on. Yes? So I have to prove you somehow that I'm the right person. With our lecture, we will use some archetypal characters, like Alice and Bob. They are like this, like in this picture. They are good guys who try to work together to interact with each other. And we also have two bad guys, Eve and Malloy, who have an ability or trying to interact with them to make them with the work the worse. And we also have the third person, Trent, a trusted person. He might be able to work as a judge for some cases. And what is authentication? It's verification of identity of a particular person, or a computer, or a system, or something else. So authentication gives you an answer how you can be sure that you're communicating with a real person. And you have three options to answer this question. You have to use something what you know. For example, you can ask me a special password. If I will pronounce your correct password, you will say, well, he's probably the one who we wanted to talk. You can also ask me if I will have special thing in my hand. If I will have this thing, like a token or something else, I will be a valid person. And the last one is something like he or she is. So you basically can check my fingerprints if you wish. If I will allow you, of course. So this is also the third way of authentication. Well, we'll start with the first one. Something you know. Basic is a password. Passwords are very well known, and everybody knows about them. They have some advantages and disadvantages. And, one option of using passwords is using, for example, one-time passwords. And they are basically used quite frequently for example, net banks and something like this. So this is probably quite common stuff for all of you. And this picture particularly shows how to log into a special Linux operating system. So just ask your password. All right. Well, this slide shows some problems with passwords. The first problem which occurs, and you can follow this link. This is new from news website. The problem of passwords is they sometimes are stored in a plain text, so anybody can just basically read them. And for this particular example, well-known Finnish website Alepa was hacked a couple of years ago, and a list of well-used passwords have been published. And you can see how many passwords, well, but just basic salasana, which is password in Finnish. This is just top 5. The 6th one, I cannot pronounce it to you because some of you know Finnish. It's a bad word in Finnish there. And you can see this is not very hard to guess, even guess his passwords. It shows this example. And there are some well-known dictionaries of passwords in the network. You can find them by basically Googling, and you can try these dictionaries on such for such users to try if they used well-known passwords or not. So it's quite interesting example. Another option of authentication is something what you have. It might be done with this one. This is iButton, and this one is some secure ID card. So you can use smart cards. What is a smart card? It's some microchip. We contains some information in a basic processor, which allows you to get this information if you just submitted correct PIN. If something's going wrong, this information might be even self-destruct. But of course, not like in Mission Impossible, but quite effective way. So if someone have something like this might be another option of providing authentication. And the last authentication option is something what you are, is biometrics. So you can have fingerprints, you can use palm scan, you can use iris scan or something else. Some of these methods quite good, some of these methods are not acceptable, good for the public, but it provides an ability to check this person if he or she is correct person itself. But it has some very interesting disadvantage. If someone stole a password, it's quite easy to replace it with a new one, right? If someone will steal an I button, it's not a problem to create a new one or start a new one. But if someone steals your fingerprints, it's quite hard to have a new ones, right? So it's possible, because it's possible just to capture it from hands or from some things that you touched. But if these fingerprints or something is compromised, you cannot replace it with a new one. Or it's extremely hard, it's dangerous for your health or something. And what else can I add for the authentication? Authentication might be not just basic stuff. It might be two-factor authentication. Then, for example, you have at least two methods of authentication combined together. For example, if you have an ATM card and PIN. What is an ATM card? Well, this is not a basic smart card. This is quite old version of card with a magnetic type there. And if you want to be sure that this card is safe, you have to also provide a PIN, check PIN number of the user. And also I have to say about additional types of authentication, because usually when we're talking about authentication, we're talking about user authentication. But it's not that obvious. Sometimes it's better to say about the server authentication. And the example of server authentication is Secure Sockets Layer Protocol, SSL. With SSL, server have to provide a certificate of itself, and you can validate if this certificate is valid for you. And by using this certificate, you can check if this is correct or valid server. So you basically can authenticate the server. So this is it. And authorization. Authorization provides you an answer if you already passed authentication, so you proved that you're a right person. So authentication provides an answer for a question, are you allowed to do this or that? And you can basically just, for example, by authorization, have an answer on the question, have you an ability to delete a file, for example, or something like this. Usually these things have been performed by access control lists or ACL. So you can use these things for authorization. This access control list usually composed like these tables, and this particular example shows how these access control lists are composed for home directories for particular users. So we have our users, Alice and Bob, and they have their own resources, their home directories, and you have privileges to access to their own directories. There are also access control models for authorization. The first one is mandatory. What does it mean? It means if you are authorized with your application, the only thing is reliable for your authorization is a computer. So the only thing what decides are you allowed to do this or that or not is the computer. Nothing else, or no one else. Discretionary, it provides you an ability to say, have you an access to this particular resource? And role-based is more complicated because it assigns you a particular role, and particular authorization is provided to this role. So if you have a role of users, you will have ability to some access to common files. But if you have a role of administrator, you have ability to do everything you wish with operating system. So this is it. And talking about different authorization levels, we can think about well-known model of Bella Padula. What does it mean? This model provides 4 levels of classifications for particular material. Top secret, secret, confidential, and unclassified. And it also provides some rules, some guidelines of how to use these classifications. For example, the first one, you cannot read up, so if you have an access to unclassified information, you're unable to read confidential information. This is so-called no read up rule. Another rule is no write down. This is not so obvious, but quite interesting. For example, if you have an access to secret information, you cannot write down this information to confidential or even unclassified level. Why? Because if you will have such ability, you will have an ability to disclose information to untrusted persons. That's why you cannot write down this rule. That's it. So this is quite interesting rule. With confidentiality, what can you say? We want to have some communication within our two roles, Alice and Bob, and we want to have them this communication secure and keep them secret from another person. So we can use different strategies to do this. For example, we can use cryptography or steganography or some other things. So you have to think about how to do this. So basically these techniques are based on so-called key, some sort of secret. This might be a string, this might be a number, but this key is a secret but shared between these two persons. If they do not have such a key, there is no such ability to decrypt, for example, encrypted information, and so on. Message or data integrity. What does that mean? This means that the data will be not corrupted. If the data was transferred between Alice and Bob, so if Alice sends some information, some message to Bob, this message have to be not corrupted when Bob receives it. So there are some mechanisms to protect data from corruption. Some of them based on hashing, some of them based on message authentication codes or MACs. We will get back to this MACs a bit later. And some problems with confidentiality or data integrity can be shown with these three lines. So you can browse for them and understand what's actually going on. For example, if Alice sends to Bob the value of x is 1, so there might be a problem what the value was changed or the assigned the variable might be changed, and so on. Accountability is another term of security. It's some I can say this is some sort of thing what allows you to say what something was done. So it allows to check if something was going wrong. So it has an ability to check if it really was there. So it's some sort of responsibility. So if someone is trying to do something wrong, something bad, these things will be recorded in some sort of log. So this is completely connected to logging in audit trails. This also requires some things like secure timestamping. What does it mean? It means that if any action has been logged, there's a need to add to this information some timestamp. And this timestamp have to be with right time. So you will require to have some sort of equal time of all of your machines to be sure that your timestamping works correctly. And also you have to think about this data integrity and of logs, because if there's an ability to basically change your logged data, there's no accountability at all. So for this reason, sometimes it's even tried to use for logs some physical devices which doesn't allow to erase or modify data. That's how it works. And if there is an ability to write or reset or destroy somehow this log, this allows an attacker to cover his tracks. It's not very good. Availability. One can say what availability is not connected with security. Not exactly. What is availability? In other terms like uptime or free storage effect on this, this is very, very valuable for some online services. So for these online services, they have to be served 24 hours a day, 7 days a week. So if these services will be stopped for a while, there will be a dramatic problems with revenue of particular organizations. So there will be a big money loss in this case. So availability can be violated by some security problems, and well known of these issues is a denial of service. This specific attack is to somehow try to turn off particular service for a while, which makes it unavailable and provide some problems to its owner. So that's why availability is also a security issue. Non-repudiation. What does it mean? It means what, for example, if you trying to buy some things from the shop, if you already paid, if you already taken these things, you cannot deny what you did not do this. If you did not pay, did not order anything, and so on. So this is also connected with login probably and such other things, but this is connected to transactions, particular transactions. So if you're connected to particular transactions, you cannot deny what you will be, or you was connected to this transaction and so on. Okay. So we finished finally with all these 7 security concepts, and let's see how see an example of how they can be implemented or how they can work. This is quite interesting and common example. We have some sort of company called PCs RUS, and this company needs to order some DVDs from another company which is called DVD Factory. And we have to think what the problem might be. So first we have to think, is DVD Factory is real company? Is their website is correct or authenticated? DVD Factory have to think if we are authenticated and so on. So let's see it more details. The first, we should start with availability. So we have to be sure what to make this business process available. We have to be sure that a DVD Factory will be available 24 hours, 7 days a week. So this is availability. If it's not available, there is no ability to perform this business action. Another thing is authentication, both for the user, so this is Bob, so he has to provide his credentials to DVD Factory, but he has to also be sure that DVD Factory is, this particular website is Jenny DVD Factory website. So also have to authenticate it with using, for example, HTTPS or Secure Sockets Layer, SSL. And confidentiality is also have to be kept here by using encrypted connection with HTTPS as well. So no one will try to see what the interaction is there between the POP and DVD Factory. Additionally, we can say about authorization. When Bob was authorized, does he have an ability to order DVDs from this site? Or he has an ability to just browse through already ordered items, to just see what was previously ordered. Also, there's supposed to be some things with data or message integrity. So we have to check if all this information have been integrity or secure. Also thinking about accountability, there's supposed to be a log in this website to track all the things what this Bob has been done during this website, during his sessions. And of course, non-repudiation, because this might be a problematic for particular websites. Well, that example quite simple. If you ordered something from the internet with your credit card, for example, you can later say, "What, guys, it was a wrong transaction. I did not do this." And the bank usually recovers your transaction. So it just rejects it afterwards, and you will receive your money back afterwards. That's how it usually works. That's why usually with websites, this is not provided because of laws. And for security concepts, what we can say? We have to say what we have 7 key security concepts. We were talking about this DVD factor example. And technological security in context is not just one way of how to implement the security. Security is holistic. Now, let's go to the systems, secure system design, how to design the systems to make them secure. We have to think about the threats and try to mitigate all these threats first. The first threat is defacement. What does it mean? It means what you have a website and your website was hacked, and basically hacker just changed its face. This is defacement. Well known is about White House website being hacked and defaced with some activists and so on. Infiltration is more problematic thing because this means what effectually, in fact, the data has been read or written by the attacker. So this means this is more problematic. This provides a more damage to you. Phishing. Lots of you heard about phishing, probably. And what is that exactly it is? It's some sort of link which comes to you from email. It might come from malicious websites, and it provides you some link to evil site where they ask you to provide some of your credentials like passwords, credit card numbers, and so on. This is it. This is phishing. You know, you probably already faced with it. Farming looks like phishing, but with phishing you basically can detect that you are in an evil site. So the address of this site you can see, and so on. But with farming you cannot see this address because this concerns about some problems with DNS. So you can see a correct address in your URL string in your web browser, but the site will be malicious. So that's the main difference. Insider threats. These threats probably are the most problematic because these threats are caused by real people who are working for the company, because they already know some secrets and they can just basically give these secrets because someone pays them for these secrets. So this is very problematic. Somehow this might be mitigated by least privilege principle when there are several levels of authorization for these persons, and the only highest trusted persons will have an ability to get an access to the most privileged stuff. So do not give an unrestricted access to everybody, please, in your company. Click fraud. This might be not very well-known thing, which is this is more connected to pay-per-clicks ads, for example, like Google ads, and there are usually two targets for this problem. First one is to click automatically on competitors' links. That's why these links will be completely violated, because they will be these links will be completely afterwards removed from showing to others. So just wasting the competitor's budget. And another one is clicking on our site, on these specific links, because this allows us as owners of this site to get some revenue from these clicks. So this is it. Two main targets. Denial of service. Usually when we're talking about denial of service, people start to imagine that there are some machines who starting simultaneously to submit their request to a particular server, and the server will not be able to process all of these requests. It just hangs and stops to respond. This is the well-known implementation of denial of service, but this might be done in a different way. If someone will just come to the server and switch it off. This is also denial of service. And the target is just to stop the server to provide its services to clients, to stop, to make it unavailable. That's denial of service is. Data theft or data loss. Well, this is also a very big problem. For example, if someone, well, there are some cases here, you can see it here in these lines. So what does it mean? The data have to be stored secure. And if this data stored unsecured, someone will have an access to this data. And there are some well-known examples of this, like some confidential data being disclosed, some confidential data of, I don't know, some citizens, some their addresses, phone numbers, credit card numbers, and so on. And this data has to be also secured, encrypted as well. And please store this key or this encryption somewhere else. Because if there will be encrypted data and a key in the same place, just use this key to unencrypt this data, and that's it. With this slide, I can provide you some sort of table with some application types and more possible significant threats for this application type. So, for example, for financial institutions or electronic commerce, there will be main threats will be a compromising of one or more accounts, because if an account has been compromised, someone can use it for his or his own needs, buy something from another person. Or denial of service. While denial of service is significant for financial institution or electronic commerce, because if this, for example, website is unavailable, this will brings very big revenue loss. Just for one day, this might be $1 billion loss. How to design, finally, the secure applications. Thinking about the security, we have to think not just on a last stage of development or designing, because the security issues, the security problems has to be taken into account during the whole designing process from scratch. A bad example of how not to do this are, for example, Windows 98 or Internet. Let's start with Windows 98. You probably know well, this is quite old operating system, but probably you have had an ability to face with it. And there's a diagnostic mode there, and you can basically press F8 button during the boot of this operating system, and you can go through this diagnostic mode there, and there will be no need even to type a password. So you can go and get an unlimited access to all the resources of this computer. Not very nice. Why? Because Windows 98 was initially designed without the security stuff, and the security issues the security features were added later, after the whole design was completed. That's why if design was completed, it's not very problematic to take it off, security from the system. Another bad example is in Internet. What's the problem with Internet? Because Internet started with DARPA and trusted universities, but later it started being used by different commercial organizations and no one was thinking about the security issues of internet, then it was just a very small one with DARPA universities. That's why there is no such out-of-the-box things for security in the internet itself. Of course, we have IP security protocol, but it's not very, very widely used. And that brings some problems for us. We have to use firewalls, we have to have a number of things, but it's not completely 100% provide us 100% assurance about this. Talking about how we can mitigate these problems with networks and particularly with internet is IP whitelisting and spoofing. So with IP whitelisting, we can try to have some sort of whitelist of IP addresses which we are able to communicate. And there's also another problem with IP spoofing attack when another malicious user tried to set his IP address of his packets to an IP address of another node. This might be done. And the third portion of this slide provides us a very interesting example. How we can, or malicious user can use this spoofing for saying what he will be another host with another IP address. He can have those attack on the right address, preventing him to reply on the requests, and also he can replace his IP address of his message backward address of his messages with this IP address of attacked node. So he will be the responsible for replying on this, and the real host will not be able to reply. Another option of how to prevent these attacks or something like is have a special IDs of these messages, which not be able to crack quickly or SIM easily. So for this reason, it might be also useful to use UDP, for example, instead, or use TCP protocol instead of UDP, because UDP doesn't provide such tokens in messages. Another good or interesting example of better architecture for security is so-called turtle shell architecture. What does it mean? We have some sort of application, unsecure, and we have some sort of cover for this application that provides some security for it. A well-known example is firewall, when we have some sort of internal network not protected inside, and the firewall tries to protect it from outer threats. And the well-known Death Star. Inside it was not very secure, but from outside it looks like pretty secure, but unfortunately it has some problems with this security, a very small one, and it was damaged because of these problems. Because if this turtle shell has been removed or somehow prevented from security, this system became very unsecure. Okay, I think it's good time to make a break. Let's take a break. Okay, let's continue after the break. So previously we were talking about the security and how to design the security. And currently I'm going to remind you what if you are performing a very, very secure application, this might be not very useful for users. So when you think about the security, think about your users as well, because they can even write down your passwords if they will not be very useful to them. So please be careful. Try to make a trade-off between your security problems or issues and the real ability of using your application at all. All security requirements actually are like usual normal requirements of application. That's why these requirements should be shared with quality assurance team and developers as well. So it's not just a basic with these security problems or issues have to be somehow added later. This should be started from the scratch, from the beginning. And also you have to think about these problems, about the functionality of your application in terms of security. For example, you have to handle your errors correctly, because if these errors will not be handled correctly, your application may hang or provide some sensitive data to attacker. So this might cause, for example, denial of service or some data reputation. So you have to think about this. And we will see validation and fraud checks and security robust later with the presentation. First, let's think about error handling requirements. You think about the basic web server application. What does it? How does it work? It just has to get some string from the user according to HTTP protocol, have to parse it and provide a reply on this string, yes, to this request. And if such request contains some data which makes the server hang or just basically ruin its execution with an exception, this will cause a denial of service because the server will hang or prevents working. This will be denial of service just with one single request. Realize, yes? How we can fix this? Well, your web server or your web application have to immediately disconnect from the client which tries to send you somehow mail format request. So you have to think about the functionality of the application, not just thinking about how it's supposed to work with correct requests. You have to think about how this application have to be designed to work with incorrect requests as well. Working with quality assurance, testing team, is also quite useful. You have to share with developers your security needs, and well, you have to check all these features of your application, including security features as well, with testing and other things like others. And there are some bad examples of how not to do. Well, the first one is the previous example of basic web application, which has some sort of exception on not well-formed, for example, not well-formed format request. And another from the real world as GGSN, as a special device for cellular phones, for these networks. It was just basically crashed if someone just sent him a TCP packet with field set to FF in hex. So this might be even more efficient than just trying to use denial of service with lots of clients trying to simultaneously send a message or a request to the application. You have to think about internal errors securely, so you have to not to provide error results to your user, because it might get some vulnerable information from your error stacks, for example. And even can think about fault injection, just trying to provide your application bad input and trying to destroy it by this input. This is called fault injection. If someone found such unwanted behavior of your application, you can he or she just have to say about this to the other members of teams, because if he or she will not try to exploit this is illegal. Exploit this is illegal. And you have to think about validation of input data. You can check the data integrity of input data. And there might be an example of, for example, credit card, where a number of credit card can be validated by module 10 checksum. So you can basically check this DICE of this credit card number if module 10 of sum of checksum will be, or this number will be divided by 10 equally. This will be correct. Some other things might be also done for credit card numbers as well. You have to write the security requirements correctly. You have to think about them very precisely, and you have to think about access control security. You have to think about auditing, how to log all the actions that users perform. You have to think how to encrypt data and some functions, because this data might be really secure or confidential data. And you have to think which particular functionality has to be available, or very available for example, 24 hours a day, 7 days a week, and so on. And also these requirements have to be in design documents, of course. Security robust example it's an example of how to deal if something is wrong with your security usage of your particular solution of your application. The idea of security robust is just not publish your application until you will not be sure if it's secure or not. And an example of Microsoft even delayed the shipment of some of its products because of problems with security. And another interesting term of security is security by obscurity. What does it mean? With security by obscurity, we're trying to make the architecture of our system as confidential as it's possible. So we do not trying to not disclose our architecture, thinking about this will make our system more secure, which is more or less well known for military systems, for example. But this is not the only thing that can be useful. So it's not very good, because, for example, attackers, they can use reverse engineering. For example, if they have a binary code of our application, they can just basically decompile it afterwards, especially if it's written, for example, in Java or in .NET. It's really easy, can be done. It's also possible just to try to use fault injection, trying to different incorrect input data on these applications, and also like this. The secret case, what does that mean? This means what usually attacker somehow, by as shown in the previous slide, he already has at least impression of how your system is designed, or maybe he has an exact understanding how it works. About he may have a good understanding of the real architecture, and usually this is just a matter of time. So do not rely what your architecture will be secret forever. But some parts of your system might be even secure even if your architecture is not so secret. So how this can be done? This might be done by keys. So if these keys are kept in a secret place, this will not be very easy to capture them. And also, do not please include your keys in your code, in your source code, in your binaries. Please keep them in a different file, because if you will include them in the binaries, it's quite easy to get this code from binaries and decode everything you wish. And also, if the key will be compromised, it's quite easy to change it. But if the whole architecture has been compromised, its replacement might be not possible. Well, some guidelines what not to do. First, do not invent your own encryption algorithms. Why? Because these encryption algorithms usually developed by well-prepared persons who have been their careers for creating these algorithms. They're special in mathematics, and they know how to do this. If you're not trained to do this, please do not try, because it's really easy to hack. Do not embed keys in software. Keep them in a different files, because, as I said, it's quite easy to replace them if it's needed. And please do not publish them somewhere like in Windows registry, because, for example, Windows registry can be read by almost everyone quite easily. Well, in all versions of Windows, of course, but in the modern, like Windows 7, it's not that obvious, but in old one, it's possible. And used well-known code, the code that you really trust it to. Don't try to create things from scratch. Use well-known implementations. And one can say we can use an open source. We can just basically publish our algorithms as an open source projects and say, guys, this will make our project secure. Or others can say, no, we have to just not disclose everything. We have to make everything as secret as possible and do not publish anything and so on. All of these approaches has a right to live, but they all have disadvantages. If you're thinking about open source projects, some way look on these projects and find some vulnerability, some problems in this code connected to security, and they may not just disclose it. They can try to exploit it, because you cannot know, you cannot assure, but the people who will read your source code of an open source project will have good in their minds. They may have something bad as well. And with closed solutions, you can just basically miss some problems with your code if you did not test it carefully. So everywhere, in every approach, you have to test your code for security issues. So open source or closed solution is not just a security issue. It's a business decision. How are you going to distribute your code? It's your decision. But it's not about security itself. Also, thinking about security is good to talk about security like a game of economics. Because one can say I can try to implement the whole possible things in security I know in my application, but this might be too problematic or even impossible, or make the application unuseful. So where to stop? Where to stop to create a new additional security features of your application? Think about this like a game of economics. And try to estimate how much will cost to break your application to hack your application by equipped person. And also estimate how much will cost for you to the salary of the person who will just have to work with this application and protect it, or somehow keep secrets of this application intact. And if this breaking system price is much higher than the salary of this person, then your application is okay from the economic perspective. So this might be $1 million for cracking the application, but the salary might be at $10,000 for some sort of time. This is quite normal. All right. And so security is about risk management. Yes, and good enough security. Think about security from the first versions of your application. Start with alpha version. If it's not correct from the perspective of security, just forget it and try again with the beta version. So with alpha version, you can just play with your application, play with your architecture, find its problems, and propose a new one in the beta version. But please take into account security first. And this is a summary for security system design. Think about threats first. Think about the application. An example of application, what can be useful there, like what threat might be there, for example, as we talked about this, like ping of death, malicious request for a particular web application which make it hunk or causes an exception of this application and makes it a denial of service attack. In fact, think about an economic game and good enough security for your design. Now we finally came to some issues of particularly web applications, and let's go with these security issues, and we start with client-state manipulation. So what exactly is a client state? This is some information what we have to store connecting to a particular transaction of particular user. And this information should be connected somehow to his or her browser session. And well, in HTTP, you know, there is no such mechanism for keep tracking of this data. So we have to implement it on our own. And one of ways of how to implement it is to use some hidden fields, for example, in our HTML files. So here is a scenario what we have to implement. We have some sort of online order form, which we're going to order some pizza. And this form calculates the price and submits the server application, part of this application, the price of the order, and we have to charge the credit card of this user to make an order. How this was implemented? For example, we have a hidden field for a price inside of a form, and this hidden field is submitted to the server inside of this form. Then this form is submitted by method get. Well, method get is quite known. It's quite easy to be implemented. And on the server side, we just can get this price and then charge the credit card. So everything's supposed to be more or less okay, but then so first we want to use a normal behavior of this. So we have to submit a confirmed price of this order, but we can just the malicious user, he or she can just replace this request, this particular price with another number, and this will look like this. The attacker may just navigate to the order form, specify how many pizzas he or she will want, submit the credit card, and he will be navigated to this form where the total price will be shown to him, and he or she will just need to press a button yes or no. And the resulting part of the code will include the price, and the user can basically change this price in this code itself. And the resulting request will be like this. The price will be changed. Quite affordable discount, right? So the hidden form fields, hidden form variables, they are not so secure in this case, because the user can see them and basically he can manipulate with them. So attacker changed the price and received good discount. So what else the malicious user can do? He or she can use some tools like this one, curl or wget, and they automate the creation of web requests according to HTTP protocol. So you can basically call this on command line tools and simulate get or post protocols, get or post requests to the server, and you will receive the result what you will need. So how we can mitigate this? How we can prevent these problems? The first solution is to use session ID. So we do not have to store any sensible information about the price or money or something on the client side. We have to store it somewhere in our web server. And we have to connect somehow this information stored on the web server with a client. So we are able to use session ID to do this. So this will be identifier of this data, which will be submitted to the client, and by this ID, this particular data can be found on the server side as well, in the database, for example. And this session ID might be stored in a hidden field as well. And with a new request, this hidden field value will be submitted. Right? Better. But in the server side, we just have to look up for this session ID from the request. And if we did not find this session ID, we will just have to reject these requests, and that's it. So it's good to have this session ID quite wide number, quite big number, composed from several DIDs, and this will be not very easy to temper it or guess it. So this might be good. And this causes also some sort of bottlenecks of performance, because there might be a possibility to create a DOS attack from another client, which will try to use different session IDs, random session IDs, just to block our server to be done. But this might be prevented. What else? What else can be done? Because the session ID it's possible to stall it because it's still used, for example, this get method. So it basically can be copy-pasted from the resulting URL string from the browser and submitted somewhere with a mail by this user, and who knows if it's safe or not? Probably not. Because anybody else can just reuse this session ID, and this session ID is viewable to user. So what else can be done? It's possible just not to put the information about the session ID to the server, to the client, but to have some sort of signature of all the sensible data of all of these fields. And how this signature will be calculated. This signature will be calculated on the server side, and if something were changed on the client side, server will recalculate all this submitted data after request will be done, and compare this signature with this result. So if they will not compare, so if they will be not equal, it means that something's going wrong and this request have to be rejected. So you can see just basically how it works. So you can calculate how it, you can see how it calculated, and this is a message authentication code, MAC. As I said previously in the first part of the lecture, we will get back to this message authentication code. So this message authentication code is calculated as a result of all of these fields combined together. So it's possible to get tempered state. But of course, with this simple algorithm, which is easy to guess, it's also possible to create a signature on the client side with correct signature, and this will not be detected as well. Another option is using a method post instead of get. Why? Because with method get, the resulting information, I mean, these values of all of the fields of the form will be submitted to the server in a URL. So user basically can see and view all of these items and even copy paste them somewhere else. With post method, it's not possible to do it from URL because URL will not contain this information. All of these things will be submitted to the server inside of the header. So this will not be like here, it will be somewhere else. And also with session ID approach, if someone will try to follow some link to another site when the session ID is already inside of his or her URL, another website will receive this information from the HTTP request from the referrer header position. So this will be not very useful because from the security perspective, because this will be recorded in the logs of another website, and who knows if the administrator of this website will be a good person or not. You may try to reuse this session ID to try to connect to our website and just try to pretend what he is, this person who previously browsed through his website. Post provides some benefits for this because there will be no referrer about this information. The referrer field will not contain this information, and it's more secure. And I would say that the difference between GET and POST methods is that the first GET method provides ability to send less data than POST method, but also POST method is more secure in this case because user cannot see in the URL what he exactly submitted there. And there will be no reference there and so on. So this might be useful. Cookies. So what is a cookie? Cookie is a small text file that is also submitted from the server to the client, and the client have to resubmit this text file back to the server. One can say that the cookie is some sort of support of the state of particular HTTP protocol. Because itself, HTTP protocol is stateless, but cookies is some sort of state for HTTP protocol. And how can we use cookies from this perspective? We can store session ID inside of this cookie. This will not be available for POST or for GET, like in GET method, because this will be seen just on the HTTP header. And it also may contain some problems. Why? Because there are, you probably know, two versions of this cookie. The first one is so-called temporal cookie, which is not stored eventually in a hard drive of user, and it will just used for a very short time. Temporal cookie and so-called persistent cookie, which is stored there, in a hard drive, and another application just basically read this text data from the hard drive and get this session ID from this text file from there. And how they will use it, no one knows. Maybe they can try to reuse this session ID to connect to the server and try to provide to change some sensible data. So cookies provide some problems. And how we can mitigate these problems? We should assign a limited lifetime for each cookie, so we should not make them absolutely persistent. We have to make them with some lifetime which is supposed to be quite short, for several minutes, maybe an hours, but not more. And also we have to think about timeouts of these session IDs on the server side. So we have to destroy this connected data to the session ID if timeout is violated, even if users resubmitted after this timeout correct session ID. So this is also quite useful. JavaScript. Well, we will talking about JavaScript quite long, yes, and you have some experience with JavaScript, and you know what JavaScript might be useful for client-side validation. But it also might be used for example, calculating the price like this. We have some sort of function compute price, which is described here below, and that's a problem we can see here. This text, this script will be submitted to the client, and client can change it. So client can change this compute price function as he wishes, and he can change the resulting price to almost zero, as in previous example. So this is not secure to calculate this sensible business information in JavaScript. You have to calculate this information only on the server side. So you can basically see it. So you can just even delete JavaScript code, so there will be no price calculation at all. So do not please trust these results of client-side validation, because the JavaScript might be just basically switched off, or might be somehow changed in an incorrect way. So the server have to additionally check everything what was submitted to the server from the client. So what's the summary for the client-state manipulation? What the problems did we see? The first one problem is what we have to somehow store the session information, some transaction information, because HTTP protocol does not provide us such ability. So we have to store this information on the server side, and we have to connect this information to the client using different methods. Good methods is using session cookie, which contains just session ID, but we have to limit the lifetime for this cookie, or hidden fields. And never trust user input. Never trust it. If you even used client-side validation, you have to recheck all of these fields what was submitted to you from the client on the server side again. Okay, SQL injection. I hope I will manage this in 10 minutes. So SQL injection is probably one of well-known type of attacks in the internet, for web applications, for example, and so on. This is quite frequently used attack, and it's still quite effective. I can also say that there are even some tools for SQL injections. So these tools allow us to automate the process of SQL injection for particular websites, so you can not just have to do everything from scratch like I'm going to describe you further, but you can also use these tools to do the same in a faster way. Well, let's think about the text scenario. So what do we have? We still have our website with which allows us to order pizza, and we have additional form which allows us to see our previous orders, and we have to specify a particular month for which we have to see our orders. And the result of this form will be an HTTP request. In this form, it will be a GET request, and you can see that this request contains parameter month equal to 10. So what an attacker can do? Attacker can modify this parameter, and he or she can put there something like month equal to 0 or 1 to 1, and so on. So what does it mean? So this value of this parameter will go to this SQL request without a change. If it was composed like this, with just concatenation of strings. Okay, very nice. Sorry. Looks like the lecture is going to be ended quite soon. What does it mean? What this particular request will look like this one. So the last string of this request will always true, because 1 is equal to 1, and the resulting screen, resulting form will contain all of orders of all of our customers, and all of this information will be compromised, because we do not want to all of these users to see what others ordered. Another attack scenario is even worse, because it allows to get some credentials of our users, like card numbers and so on. So if there will be parameter month equal to 0 and 1 equal to 0, so never. And another portion of this request union with select another request select, the result will be like this. Of course, sometimes it will be not so beautiful. Sometimes it might be just basic error message, but even from this error message, it's possible to derive such an information. So you can see how to compromise another more sensible data. Even worse might be if we will try to put a drop table. What does it will be? What does it mean? A denial of service, because the table credentials will be completely destroyed. There will be no such table, and this will cause denial of service for a whole of application, because application became unavailable anymore. So this is not very good. This is completely bad. And what else? It's also possible to modify some data. So it's possible to even drop like this table, or yes, attackers. This is able to drop this table in a bit different way. So how can we mitigate all of this? There are several solutions. The first one is defense in depth, when we have some stack of these solutions, some stack of these prevention techniques, and we have to use them simultaneously. The first one, a simple one, is whitelisting or blacklisting, where we just filter in some strings or particular characters in the strings and not allow them to use in the final parameters of SQL requests. We also have to use validation and escaping of input parameters of our application, which we are going to use in these SQL requests. And another one is prepared statements and bind variables, which is quite useful for both Java, C# or PHP as well. And try to mitigate some impacts, try to mitigate some possible loss caused by SQL injections. So we will start with blacklisting. So what is blacklisting? It's just if we can try to filter these request strings, and we will try to do not allow some strings which contain some quotes, which was used in the previous example. So would it be useful? Apparently not, because it's really hard to remove or think what symbols will not be allowed for this particular parameters. Maybe it will be white space or something else. So it's quite easy to miss a dangerous character then. And also, what can we do? For example, if we are filtering this this symbol here, but if we would want to use, if we want to store O'Brien in database, for example, this good string does not contain any malicious code, but will be rejected in this case. Not very good. A solution to this is whitelisting based on input validation. For example, this input validation might be performed by regular expressions, which you are also familiar with. So you can basically check if you expect for a particular parameter to be an equal number or something else to check if it's so or not. Escaping is also another ability to mitigate this problem, to prevent it, because, for example, it will try to double these symbols like this, and it will allow to even store this string in our database without a problem. And talking about SQL injections, we have to say second-order SQL injections. What does it mean? Second-order SQL injection does not just basically explore particular parameter, it also uses some data was already stored in the database. These data might be stored even as a result of another SQL injections. Well, for example, we can use this request to update the password of particular user. Not very problematic. But if we will have another user there with this interesting username, which was not escaped for some reason, and we will try to change the password, so basically this request will look like this, and this request will finish at this place of the string. So what it be? It will change password for administrator of this site to the wanted parameter. Not very nice, not very useful, not very safe, I would say. So this particular SQL injection uses this particular username that was already stored in our database. Right? So you have to escape all dangerous parameters then. Prepare statements and bind variables. What does that mean? Well, the basic idea of creating SQL requests by just concatenating strings is not very good, because there's an ability to create an SQL request, parameterize it, this SQL request, if all of these parameters been assigned to particular values with particular types. And this technique is prepare statements and bind variables. So this is an example in Java. We have some sort of SQL request with some parameters with these question marks, and these question marks will be assigned to particular parameters. And these parameters has particular type. So it's quite easy to check this type of these particular parameters. With PHP, it looks pretty the same. The difference is just the syntax. And one can say that stored procedures may help us to mitigate these SQL injection problems. From some reason, yes. From some point of view, yes. But it all depends on how we are going to invoke these SQL stored procedures. If we are going to still concatenate parameters of this invocations of these stored procedures, we will have the same problems like this, like in this example here. So it's not very useful. So we also have to use bind variables here, for example. This will be more useful and safe as well. And how can we mitigate the impact of possible SQL injections? We have to prevent schema and information leaks. So if an attacker knows the schema of our database, basically he knows how our tables named and how our fields in these tables are named. So then he is able to attack us. Limit privileges for our database. So it means that a least privilege principle has to be implemented. So not only one user has full access to all of our database for read and write and so on. So basically this is it for today. Now I'm continuing after the break. So encryption of sensitive data is stored in databases is required if we don't want to allow malicious users to read the data what they already got from the database. But unfortunately, don't forget what some databases provide an ability to encrypt and decrypt the database information at the same moment. So in this case, users will be able to read this data otherwise, in any way. Also, it's also possible to harden DB server and host operating system. So we can just basically protect better our database server, do not allow its access to the internet and so on. And also don't forget about applying input validation, because all the information required by our application has to be validated, and during this validation process it's possible to detect if there are any parts of the SQL request inside of this input data. So it's quite easy to reject such requests. It's quite important to prevent database schema not being disclosed, because if malicious user knows about the schema, it makes it much more easy to make requests to its database, to our database. But even without the knowledge of this schema, it's also possible to use so-called blind SQL injections. With these injections, it's possible to get some information about the schema, to figure out which tables are there or fields. So it's also possible to do this even without knowledge of the schema. Also, don't forget to not display detailed error messages in case of some exceptions, because these error messages may contain some information about the database or exact information from the database, not just names of tables or fields. Don't forget to limit privileges for your users of your database, because it's quite common pattern when there is only one user who has unlimited access to the whole database, and this is the only one user which is used by the whole application, despite of the real role of this of users of this application. Because, for example, both administrator and both normal users can have the same account for database. So for this reason, it's also quite good to have different users with different privileges for each role of your application, particularly for database, of course. Because if normal user will not be able to modify some data in database, malicious users will not be able to do this either. Sensitive data is better to encrypt, but this encryption has to be done not in itself, not only on database level. This encryption and decryption itself have to be performed by the application, because if the encryption has been performed by features of underlying database server, this database server will unencrypt this data in the results of SQL requests. This database-based encryption works only for binary data inside of database files. Don't forget to think about protection of direct connection to the database server, because these connections allow some users to submit some requests to this service. So it's better to avoid such situations. Input validation of input data is quite a common thing, and may be done quite easily by basically checking all requests to our server by basically using whitelists or regular expressions to check some parts of if any strings if any request what comes to our application contains some malicious code. And also it's quite good to check the length of these requests, because usually these SQL injection requests, they contain a big number of characters, so quite easily to check them by this additionally. So finally, we came up with summary for SQL injections. So still, SQL injection, despite its quite old and famous old age, and because of its famous, it's still quite valuable and sensible, useful attack for many internet web service. So that's why we have to protect from it. So it allows to compromise sensitive user data. It allows to even provide a denial of service attack. So we have to be. Well, there is not only one solution for it. We have to provide some sort of different levels of protection, like whitelisting and input validation with escaping, and also might be useful to have SQL store procedures and use only bind variables for requests, and also input request validation is also needed. So everything in Glance might have to be done. And finally, we come up to the password security, which is quite an interesting part of our lecture. And let's start with a quite simple approach of how to store user names and passwords. The basic one is just store them in a basic text or plain text file with a combination of username and password. And this approach is not safe because this is quite easy to get information from this file. So once this file has been installed, all user passwords have been compromised at the same moment. For this reason, currently in most of modern information systems, passwords are not stored in plain text. Usually, there's special techniques used named hashing is used to encrypt these passwords in so-called one way. So there's no way to decrypt back these passwords from the hashes, and also it may say that even if initial parameter for hashing function, initial parameters for hashing functions are pretty the same, the results of this function will be quite different. So for similar strings, hashes might be very, very different. And these lines of code provides these hashes for particular strings proposed in the previous slide. And also, I can say what we are going to use H as a definition of hashing function. So how basically hashing works? It allows us to not store passwords in plain text. And for example, if a user have to be authenticated with a server, the server first asks user for its name and passwords, and user replies, and then server just calculates again the hash for user passwords and check if it's equals with the hash stored in the database of the server. So this is only one-way encryption, and that's why we are able not to store passwords in plain text. However, even if we have hashed passwords, it's also possible to steal these passwords, hashes of these passwords with usernames. And then it's possible to use attack against these hashes by basically brute force, like trying different passwords, calculating the hashes and comparing hashes with captured. And according to this, there are two kinds of attacks: offline, when we have all hashes of passwords in a file in an attacker computer. An attacker just basically have to check all of this. Can use brute force in his own computer. And so-called online attack, then this attacker has to submit his request to the server because the attacker is unable to get these hashes on his computer. So, in case of these attacks, which allows to even if using hashes to get these passwords back, there is another technique called salting, because we can add some text information, some random text to the password before hashing, and this additional information is called salt. So this basically made look like this: that we have our password combined, concatenated with some random string, and our hashed password is called also salted hash. That's why we also have to store in our user database not just basically usernames, their hashed passwords. We also have to store their salts for our passwords. And this also usually helps us to prevent brute force attacks to our hashes. So even if our hash has been compromised, it's quite problematic to crack them all. It's also quite easy to calculate how many variants of how many combinations have attacker to take into account before he will be able to crack our passwords. So it might be quite a big number, and this usually takes lots of time. And this time might be basically utilized to create a new passwords for all our users, and the stolen passwords will not be valuable anymore. And you can see basically what how this might be. Like if we have salted hashes and malicious user or attacker stole them, so if he doesn't know our salts, it's quite problematic for him to get this. And even if he knows this salts, the attacker needs to try all combinations of all possible symbols in dictionary or brute force combined with our salts. This might be very, very complicated. Okay. But also, anyway, salting has some disadvantages because the brute force attack is ineffective for the whole users list, but it's quite useful for chosen victim attack. So if a hacker or attacker wants to steal the password of a particular person, even if the password is hashed with salt, it's not so problematic. It takes quite normal time to crack it afterward. So anyway, it's better to keep all hashes of all passwords and salts in a secure place. With online dictionary attacks, it's also possible to try different well-known combination of symbols usually used for passwords. And in the beginning of the lecture, I showed some frequently used passwords from Alibaba, so you can see, but the problem is not problematic to get these combinations. Try them first. And there's no need to try all the combinations of all possible symbols, because with dictionary it's much, much faster. So all these dictionaries, it's also possible to find them in the internet by basically Googling, and this makes the work for attacker much, much easier. How we can protect from all these problems with passwords? There are several techniques, and we are going to consider them one by one, such as strong passwords, honeypots, filtering, and so on. Let's start with strong passwords. The strong password requires to be composed from symbols with different case. Symbols have to be not just letters, they have to be dice and also special symbols. And also these passwords would be better to create it so that it will not be a basic word or a combination of well-known dictionary words with some additional symbols like the dice. There are several techniques. There are several even applications allows to generate such strong passwords automatically. And one of these techniques is also like a creation of passwords from a phrase like this into this. So you can basically see that each first letter of each word is transferred into one specific letter in this passwords. And don't forget what strong password has to be composed from quite big number of characters. And of course, it's better to protect password file or password storage, so normal users or limited privilege users will not be able to even read these passwords or hashed passwords file, of course. A honeypot passwords, it's so-called not useful but very attractive for not used or maybe usual users' passwords and usual usernames. So these special users, they do not have special permissions for our system, but they have quite affordable usernames. They call honeypot. Honeypots. For example, this username may have a username like admin or something else. So if an attacker will try to find, if an attacker will receive a list of usernames and hashes, will try to find first users whose username is equal or like an admin, and they'll try to crack them first. So even if we'll succeed with cracking these usernames, we will not receive a good full control of our system. So this is called honeypot. It's like hiding of normal administrator. Password filtering. What is it? Usually, users allowed to provide their own passwords, and while they are changing or providing their own passwords, it's better to check this password for the strength and filter this not safe passwords. Though. Just basically allow users to have their all strong passwords only. So this is quite obvious. Aging of passwords is also required because if the password has been used for many years, the probability that this password has been compromised once is quite high. So for this reason, all passwords have to be changed from time to time. Sometimes these passwords might be changed only because they are aged or they've been used for several weeks or days. In some cases, password might be aged only if it has been used several times, or maybe aged by number of according to the number of the specific counter. Pronounceable passwords. It's also quite useful thing for users because for user passwords is not very easy to remember. And sometimes it's good a way. It might be a good idea to provide a user some sort of phrase or an ability to remember this password quite easily, and provide the ability to just not write down this password somewhere. Limited login attempts is also very useful if we want to prevent some attacks to our system, and this basically can be implemented by blocking an account or locking an account after 3 or 4 unsuccessful password typings. Well, of course, it might be very useful, and everybody knows if the owner of ATM card will try to enter PIN 3 times simultaneously at the same time, 3 times incorrect PIN, the card will be blocked, and he will be the owner of the card have to ask the bank to unblock it again. We can have such feature in our systems as well, and this prevents online attacks on our systems according to passwords. Artificial delays is another technique that allows us to prevent such online attacks, because with artificial delays, if a user typed his password incorrectly, the next ability for him to submit a new password to our system might be in several seconds later. So, in case of attacker, it will not provide him ability to ask the system lots of passwords. But this feature has to be implemented carefully, because if it will be implemented like if any user will enter incorrect password, the system will just basically freeze for several seconds. So this may affect on our users and availability of function. And this also might provide another unwanted problem, like ability to create a DOS attack. Last login is also quite useful technique for password protection, or some sort of not just protection. It's not a good way. I can say it allows to determine or detect if there was an attack or something, because once with last login feature, user is able to see the last location and the last time of the user interaction with the system. For example, if user usually logs in monthly from California to the system, and it was logged in from another place in an unpredictable time, so this might mean what to the system there was some sort of attack to the system. It's quite easy to detect this attack and prevent it. Another ability to work with passwords is so-called image authentication. The idea of this approach is to show user a special image what he or she selected before when he or she was registered in the system. And if user does not see this image, which cannot be spoofed by attacker, user has to be instructed to basically not to log in to the system. And this was implemented, for example, in Bank of America website. One time password is used just basically one time, for example, just to commit specific transaction, and it quite widely used in modern information systems. So finally, we came up to the conclusion about the password security. So first, we have to use hashed passwords because they have not be stored in a clear text. We have to be prepared for dictionary text because these dictionaries are well known and it's quite easily, they might be quite easily downloaded from the internet. We have to protect from them. And we have to use salts, and we have use additional approaches like one-time passwords if we need it, and so on. And finally, we came to the last part of our lecture, which is devoted to cross-domain security of web applications. And particularly in this section, we are going to talk about the situations when user of our website, which might call it my 3W service, www service, has opened in another tab of his own browser another website of hackers. So this is a malicious website or malicious web application. And we are going to talk about this situation and problems caused by this particular situation. So to talk about this situation, we have to say how these two sides, how these two applications on the client side can interact with each other. Which abilities do they have? First, they can use links to each other, and they also can use script inserts in their pages, like JavaScript in certain specific web page, and this JavaScript might be loaded in another page and being executed in the context of another page. And there's another problem, so-called caches of authentication, because in many situations authentication has been implemented with cookies or HTTP requests, and these requests and cookies might be basically cached and in a browser, and the next request maybe a card from the same browser with these cached values. So this might be a potential problem from the point of view of security. And now let's go further and realize what features of modern browsers provide us such problems. Modern browsers usually use the dynamic HTML. It means what we have support for context style sheets and CSS. We are using JavaScript in our pages, and we are able to interact with this JavaScript with a document object model of our web page and modify it in a way we wish. All these requests are recognized according to the origin, which is composed from protocol, hostname, port, but not a path of specific URL. So this particularly means what all these pages have, if they have different origin, they are executed separately. So one page, one JavaScript of one particular page has no ability to affect on a document object model of another page if they have different origin. And there is so-called same origin policy, which declares how it should be done. Here's an example of same origin and different origins of the page. For example, these two lines are the same origin because they have the same protocol, the same port, and the same address, but they have different path here. So this means, but they are from the same origin. Here we have the same line as here, but these three lines have different origins because the protocol is here different, the port number is different, and the address is also different. So that's why all four of these lines they have different origins. How basically websites, client-side may interact with each other. The first quite obvious ability to do this is to use links. So basically, anchor element of the page of HTML allows to navigate between these HTML pages. Itself is not a problem, but with other things it might cause it might bring some problem. Also, one page can include another if it uses so-called iframe. It's an embedded frame of one of another. This is more complicated. This is more interesting because a malicious web page may include our web page inside of it with iframe. And in this case, still same origin policy have to be utilized, and it prevents some unwanted behavior, but unfortunately, this is not the complete protection. So how possibly interaction may come? The first one, if a malicious website, if malicious web page contains a link to our script from our website like this. This means that the script from our website will be loaded into malicious web page and will be executed in the context of this web page. And who knows if a hacker prepared already to this? He may or she may just basically implement some other JavaScripts and prepare a special document object model for our special script, which will just basically allow him or her to get some sensible information from our JavaScript. So this might be one option. Another option is to use a form, because in this particular example we have some form which sends a request with method post to our website, and it contains a parameter with name key CMD with a value of do something. And this particular request from this form will be submitted transparently from the user. The user will not be able to even see this form on a screen because this form doesn't contain any visible elements, and this request will be submitted automatically once the page will be loaded because of this JavaScript. But the problem is, the request will go to our page and it will go from the context of another one, a malicious one. Well, other problems what may be. These problems caused by HTTP request authentication, which is implemented with special HTTP headers for user credentials like username and password. Another option for authentication is using cookie authentication. So usually in this case credentials are not submitted in the form, but they are submitted in a post request, and reply on this request with server will contain a cookie with session ID or a session token, and this cookie also might have to be sent back to the server. So these options allow us to use authentication, but these options might also be utilized, exploited by malicious users to get some problems for us, to provide some problems for us. There are two types of cookies, temporary and persistent ones. Temporary cookies are cached until browser is not shut down, but persistent cookies may be cached until some expiry date and may be stored in files of operating system for several days even. And if these authentication credentials already cached in memory, so this credential might be submitted back to the server automatically without any additional information requested. So this is possible to submit this authentication token with the cookie and say what the browser session has been continued in the context of the previous user. So how this actually might be highlighted with a specific scenario? Well, first, our well-known Alice has a browser window open and she creates a new window to visit our good site with authentication credential has to be stored. So our site sends her credentials, authentication cookie or with authentication token. When Alice just basically closes window, but the original one, original window is still open, and later she, for some reason, was arrived to hacker's site, and this hacker site has an ability to submit a request to our site and reuse cached credentials from this cookie. It's maybe even worse if credentials persisted. So if this credentials provided in persistent cookie, not a temporal one. So these credentials might even be stored and reused later, even several days after. These cookies might be timed out, and it might be even several days later. So which attack patterns might be used in this case? There are three of them: cross-site request forgery, cross-site script inclusion, and cross-site scripting. Let's consider all of them one by one. I will start with request forgery. So what's the idea of request forgery? So the malicious site can basically request our application, good application on behalf of Alice, even without her knowledge, if there will be ability for the site to submit a request to our site in the same browser session. So there's no need for any special thing on another site. This site just basically can have a form, and this form may contain some sort of password input type, and this form, if it will be submitted to our particular website, it may just basically cause a change of password, because actual credentials or authentication token with cookie will be submitted to our site with browser session once it has not been finished. So if Alice, user, will not finish his session, or basically did not log out, so this might be possible. And here's an example, with more detailed description. So, for example, Alice browser loads a page from bad guys, and then in this form from this website, it contains some sort of password input field, and the form which contains this input field is shown like this, and this form will be submitted automatically once she will load it. So browser will send authentication cookies to our application, and that's it. There will be an ability to basically change the password for this particular user, for example. What can a malicious user do with using request forgery? Well, user can basically read info, but also can make write requests to our application. And in the previous slide, it was shown how it might be done. And who have to be worried about this? Who have to be worried? Well, all applications with server-side state. If this state contains some sensitive information, and it usually contains, for example, user password, this password might be updated by using like this. And you can see, you can browse through these kinds of these websites what contains such sensible information. So, for example, with some electronic commerce, currently with this bank client system, the normal interaction looks like this. The Alice, good person, goes to this bank. Bank replies with some sort of HTML form in HTML file login, and receives also after Alice been authenticated with this bank, the bank provides her authentication cookie with session ID. And afterwards, Alice is able to submit another request to that server with a parameter view balance, and the cookie will be submitted automatically, and the server will reply with an amount on her account. And how this might be changed with cross-site request forgery attack. Alice is still logged into the bank home, and simultaneously in another browser tab or window, she will open evil form. And this evil form may contain, from the evil work website, if this form may contain some image with SRC attribute which contains a request to our bank home, and this request contains some command to submit some amount of money to special bank account. And this will happen because once the user browser will see this HTML code in the page evil HTML, this browser will submit this particular request to bank code. This request may be seen here. And the problem will be that the browser will submit a session cookie there, and this transaction will be performed, unfortunately. So this is an attack. Let's take into account another problem, another type of attack, a cross-site script inclusion. So the idea of cross-site script inclusion is based on using scripts from our site in a context of another website which potentially might be malicious. So no one can prevent another website for including script from our website. Usually this is a static script inclusion, and the problem will be what our script will be executed or invoked from the document object model or from other scripts or on malicious website, and who knows how they will try to interact with our script. And another problem will be if we will, for example, we'll use Ajax with dynamic scripts of JSONP, for example, and this might also contains some very sensible data, which comes from our website, from our web application. So what can be done? The malicious website can basically request a dynamic script, and this dynamic script will come from our good website. The browser authentication cookies will be sent, like in the previous case, and for example, a script or a JSON fragment will be returned from our good website, and this information. This script fragment may contain sensitive information, for example, about a user account or no amount of money on this account. And the hacker's web page will receive this JSON fragment, and it will be able to perform some unwanted actions with this information. So let's see it with an example. For example, we have a server with a client, and client sends request to the server, just submitting their request, which will have to return a special JSON fragment, which contains some sensible information about the user account, like amount of money there, and information about the user, and so on. And basically, on the client side, in a good website, there is an update header function of JavaScript will be invoked automatically. Then this reply on this request will come to the client, and it have to done some good things. So if an attacker will try to attack on these things, this function like update header might be changed in a malicious web page, and the sensible data will still be submitted to this function, to this updated function, and the attacker will receive this sensible data, and he can do something wrong. For example, in this case, well, this particular script is part of not good script, not from the malicious website. So you can see that the update header function was redefined here, and for example, if the account balance is higher than 100, probably dollars or euros, doesn't matter. So this information might be used to even invoke another function which will change the client's web page view, or I mean by using document object model modification of this particular page, and the user, for example, might be asked for his or her password, and if this will look like phishing, and if user will submit his or her password, the attacker might receive a full access to this account of this user. So there's another example with Ajax script. So particularly we have dynamic script inclusion with this Ajax script, and there's this particular script uses XML HTTP request function call object from the JavaScript library, and it also submits some data to the good site bank.com, and received information might be utilized to reflect on the page. And with normal Ajax interaction, it will look like this. So user first authenticates with the server, and he will receive a session ID. Then with the view balance HTML, this user will submit a session ID with a cookie to browser, and this page will contain some JavaScript will submit a special request to the browser, to the server, which with this information, and the server will reply to this particular Ajax request with this particular information, and later this information will be rendered in the page. The attacker may just basically go in a similar way. Then the user is authenticated with bank. If user simultaneously opened the evil form from evil website. This form may contain also require a query for Ajax to our good website bank.com, but the script will be a bit changed, like the script for a callback function render data will be changed, and the script particularly may send some sensible data to our evil user. So the request will be submitted to the bank, and bank will reply to this evil HTML page, and the script will be invoked, and this sensible data will be submitted to the attacker. Another type of attack quite known is cross-site scripting. You may notice, but the abbreviation for cross-site scripting should be CSS, but CSS is well known as cascade style sheeting. For this reason, for cross-site scripting, the abbreviation is used is XSS. So what is the idea of XSS? You probably remember how an attacker can use SQL injection. Then he or she just basically submits some parts of SQL request in some forms, or put them in some parts of HTML requests. So why don't this user can try to instead of parts of SQL requests use some parts of JavaScript. So let me show you this with some particular example. For example, we can have with our good website some search engine, our handmade search engine, which will serve this kind of requests, and the resulting page for this search request will contain some paragraph which will be composed from the parameter of this question parameter, the value of this question parameter. And if our website is not checking what the contents was of this particular parameter, this value might include some unwanted data. For example, if a malicious user will submit a query like this, so you can see this is a part of URL escaped JavaScript. The result on the client browser's page will contain something like this, and this is a normal, usual JavaScript. And this JavaScript was written by a hacker, for example. So this is malicious script, might be. What with this malicious script can be done? Well, basically, it's the first one is what can be done is still a cookie, because this malicious script will be executed in the context of our good web page, and it will be able to get an access to its document object model, and the most wanted thing there is a session ID or session token, authentication token. And these authentication tokens and this sensible information might be stolen and submitted to attacker's web page. So he or she will be able to see our authentication cookies, for example. Another things is what can be done with XSS is to get some more complicated information than just basically authentication token, like more oriented. If this script will be more oriented to specific web page, it's possible to get a special user information, transfer funds, and so on. So it's not more sophisticated than just stealing the cookies, but it's also even possible. And well, this might be not detected by some well-known mechanisms, because the script will be completely executed in a context of trusted page, which is a problem. It's also possible to even modify the page, because because the script will have an ability to manipulate with document object model, and this allows to have some sort of form for resubmitting a password, resubmitting some sensible information like credit card from this user, and the user will not even notice this because the address of this page will be the same as with correct browser, and this not will be detected with SSL, for example. So this will be a problem from the point of view of security, and this is quite might be easily for social engineering. So how this untrusted data, I mean, these malicious scripts may come to our application, and how our application can detect them. The first source is query parameters and form fields from HTML form. Well, this is a quite well-known source of data of requests to our application, and this information has to be validated and has to be sanitized first before it should be processed. Also, it's possible to enter some part of URI, I mean URL, Unified Resource Identifier, or URL into the page with document not found error as well. It's also possible to detect if referrer is not ours or so on, and this untrusted data might be submitted to our website and stored in SQL database previously. So this information might come not from the user, of course it will come initially from user probably to SQL, but it might come, for example, with SQL injections, and this information may basically be stored in the SQL database, and then if this information has not been validated during the submission of reply to the client, to his browser, so this might be also a problem for this user, for his or her browser. So for this reason, there are two types of cross-site scripting: reflected and stored. A reflected cross-site scripting means what the result of this script injection will be shown immediately to this particular response with this particular response with its this response to particular request. But with stored cross-site scripting, this malicious script will be, for example, stored already in a database, and it will be shown to all users who visit this particular web page. How this can be done? For example, in social networks, in blog engines, it's possible to submit some commands to a particular article or to particular text, and if this submitted text does not contain, was not validated for presence of JavaScript, for example, this text will be stored in database, and then other users will view this page. This text will just basically go to the browser from the database, and it will be shown as a part of this web page. And if this part will contain JavaScript, this JavaScript will be executed in the client side. So this is stored cross-site scripting, which is more dangerous because for reflected cross-site scripting, the only one user usually affected. But with stored cross-site scripting, once this script was injected, the script will be shown to a big number of users, to several users at least. So in this case, it could be a good idea to check everything, what also not just comes from the user to our application, but also to check what our application submits to our users. There is a good example of how this scenario was realized in myspace.com, and there was a cross-site scripting worm there, and it was very, very hard to heal the whole system from this worm, because it just basically resends it again in different replies, in different commands everywhere. And how to prevent all of these approaches, of all of these problematic techniques with all these injections? Well, we start with cross-site request forgeries. So we have to check that these requests originate from the same web page, from the same website what we are using from our good website. We also can check referrer headers from HTTP requests, and also we have to validate all. We have to include some sort of user-provided secrets in our code, in our web page, for sensible actions. For example, like one-time passwords, and this might be also quite useful. And also validate action token, for example, by checking on some special parameters of it, which might be implemented only in our secure web pages. From another attack, it's possible to use the same techniques or similar techniques, like authentication with action tokens. It's better to use post requests than to get requests, and it's better to prevent some scripts to be checked there, to check their scripts what we're going to use. And from cross-site scripting, we have never trust any data from browser, and any data when it goes to browser, we have to sanitize it, we have to use whitelisting, and we have to check if there's anything like this there in this code. And of course, all of these problems might be additionally checked with secure browsers, but unfortunately, perhaps there is no such browser which prevents completely all of these attacks. So the general considerations about all of these cross-site problems with web pages is to use input validation and output sanitization, and also to use HTML escaping when we are when we are getting information from the client requests and storing them in database, because if all these JavaScript insertions, injections will be escaped, they will be basically plain text from the perspective of HTML, and they will never be executed in the client side. And here is a table which summarizes some types of XSS attacks and how to prevent them. So we basically have to check with our whitelisting, with, for example, with regular expressions, such things like simple text when being executed, with what was added as, for example, a command to our Web 2.0 website. We have to check tag attributes, and these attributes have to comply special rules, which is quite useful to be implemented with regular expressions. It's also good to check scripts inserted. It's good to check style attributes, because they do not have to contain special JavaScripts, and of course the complete JavaScript injections has to be removed. And it's also good to check if we are going to submit HTTP header of our web page, if it contains message 302 or like multiple of particular location. This will cause a redirection of particular website to another, perhaps malicious website. So we have to check if we are actually submitting correct request to our correct reply to our client, our website. And finally, we can come to the conclusion about cross-domain security for web applications. So there are several types of these attacks. These attacks are usually launched against the particular applications, and they initiated from the client side, but not on the server side. And this might be prevented by using more safe HTTP requests like POST instead of GET, and validating and sanitizing input and outputs. And this is it. This is all for the current lecture. Thank you very much for your attention, and I hope this information will be good and useful for your future work. Thank you very much.